This is the first solution and this is the second solution. If first solution's osmotic pressure is X and second solution osmotic pressure is also X, then these two solutions are called as isotonic solutions. How can we say the solutions whose osmotic pressure is same is called as isotonic solution. When you mix these two solutions, no osmosis generally takes place, right? Isotonic means so they should have same osmotic pressure. They should have same osmotic pressure. They should have same osmotic pressure. Same number undali. So then you will say it as isotonic solutions. Right? Yeah. Next I'll give another situation. Let us say this is one solution, one compound. So this is the second case where ikkada chudandi namma koncham confusion start avudhu ikkada, but you can make it easy. Let us say everybody knows the animal called amoeba. Do you know this? 10th lo untadamma, it is a shapeless animal somewhere else, right? Right? Amoeba has got like iska structure kuch ठीक नहीं होता, ऐसे कुछ होगा, right? इसका shapeless molecule, it always changes its structure. This is amoeba. Let us say here I have a solution. In which I put this amoeba, right? Amoeba is placed inside a solution. If the osmotic pressure inside the amoeba body and outside in the beaker, if they are same, you call them as isotonic solutions, right? So if they are isotonic solutions, nothing happens, right? So that is the first case we have seen in the beginning. Now I'll give the different situation. Situation is different here. We'll make unequal. Assume that इसका कुछ concentration के term में चेक करेंगे. इसका concentration कुछ 1 molar है, इसका concentration कुछ 0.1 molar है, right? Why I am concentrating on the concentration? Because pi is equals to CRT kada. So pi and CR equal hai. So higher the concentration, higher is the pi. Lower the concentration, lower is the pi. So this is the first situation, and this is the another situation where amoeba pH is going to be 1 molar and here the pH is, let us say, 2 molar. So what is the differences do you see in these two cases? చెప్పండమ్మా, రెండిట్లలో డిఫరెన్స్ ఏముంది? రెండిట్లలో డిఫరెన్స్ ఏముందమ్మా? Are they in the same structure or are they in the same kind of environment? So here in amoeba, concentration is greater than the outside solution. Here concentration of amoeba is less than the outside solution, right? Correct enough? Both of them have different concentrations. If that is the case, here osmosis comes into picture. Osmosis should take place. Osmosis happens here. How osmosis happens here? చెప్పండి, ఇక్కడేం ఆస్మాసిస్ అవుద్ది, ఇక్కడేం ఆస్మాసిస్ అవుద్ది. How exactly the osmosis is going to take place? If you put two unequal solutions which are separated by a semi-permeable membrane, any animal membrane or plant membrane can act like a semi-permeable membrane. So what do you expect here? అందుకే ఫస్ట్ క్లాస్లోనే మనం చూసాం, if osmotic pressure, if a chamber is divided into two equal halves, एक तरफ 0.1 concentration है and एक 1 concentration है. So how the osmosis takes place here? low concentration to high concentration, the movement of what takes place? Solvent particles takes place. So here the water will be moving out of this first chamber into second chamber. కరెక్టేనా? ఇదే కదమ్మా మనం ఫస్ట్ చూసింది. ఇక్కడ ఏం కావాలి? లోపల కాన్సన్ట్రేషన్ ఎక్కువ ఉంది, బయట కాన్సన్ట్రేషన్ తక్కువ ఉంది. వాట్ షుడ్ హ్యాపెన్? చెప్పాలమ్మా, అన్మ్యూట్ చేసి చెప్పాలి. వాటర్ లోపలికి పోయిద్దా, లోపల ఉన్న వాటర్ బయటికి వస్తుందా? బాలరాజ్ సార్, పిల్లలు ఉన్నారా సార్, పడుకున్నారా?
సార్
ఉన్నారు సార్. రెస్పాండ్ అవుతున్నారు సార్.
చెప్పాలమ్మా, చెప్పు. ఎస్,
హైయర్ కాన్సంట్రేషన్ నుంచి లోవర్ కాన్సంట్రేషన్ కి వెళ్తారు సార్.
ఇక్కడే చూడు, ఇక్కడే ఉందమ్మా, ఇక్కడ
లోవర్ టు హైయర్.
ఇది లోవర్ కాన్సంట్రేషన్, ఇది హయ్యర్ కాన్సంట్రేషన్, అవునా?
వాటర్ లోపలికి వెళ్తాయి సార్.
సో ఇక్కడ నుంచి ఇటు వాటర్ లోపలికి వెళ్తుంది కదా, ఎప్పుడైనా వాటర్ మూమెంటే ఉంటుంది. ద మూమెంట్ ఆఫ్ వాటర్ ఈజ్ ఫౌండ్ ఆల్వేస్. ఇక్కడ ఇది లో కాన్సంట్రేషన్, ఇది హై కాన్సంట్రేషన్. సో వాటర్ ఎంటర్స్ ఇన్ టు ద అమీబా కదమ్మా. భవిత చూడు ఒకసారి, లో కాన్సంట్రేషన్, high concentration, right? Here what will happen? So low concentration to high concentration, so water will go outside. If this kind of phenomena takes place when an amoeba placed in a water, so what should happen here? So here amoeba, shapeless amoeba should become ऐसा explode होना चाहिए, गोल गोल बन जाएगा. If it continues, what will happen? So it will explode, isn't it? But here what will happen? The amoeba further shrinks into the smaller and smaller because water goes out of this amoeba. అర్థమైందండి కాన్సెప్ట్? అర్థమైందా? యా, అమీబా సంగతి వదిలేండి, వేరే కేసు ఒకటి చెప్తా చూడండి. సో ఐ హ్యావ్ టేకెన్ 2 beakers. ఇన్ ఫస్ట్ బీకర్ ఐ పుట్ సాల్ట్ సొల్యూషన్. ఇందులో హై కాన్సన్ట్రేటెడ్ సాల్ట్ సొల్యూషన్ పెట్టాను నేను. ఇందులో ఒక గ్రేప్ వేసాను. సో దిస్ ఈజ్ ద గ్రేప్ ఫ్రూట్, ఇస్మే मैंने डाल दिया సాల్ట్ వాటర్లో. సో వాట్ షుడ్ హ్యాపెన్ చెప్పండి? అండ్ అనదర్ కేస్ I take a resin. Resin అది ఇట్లా ఉంటుంది కదమ్మా, resin. This is resin. Resin నేను ప్యూర్ వాటర్లో వేసాను. So this is pure water. What will happen? So here the concentration is higher. The concentration is higher. Inside the grape concentration is lower. Therefore, exoosmosis takes place here. Osmosis takes place in exoosmosis. What do you call this as? Exoosmosis takes place. So this grape becomes, क्या बोलना चाहिए? This grape become resin, and whereas here the outside the concentration is low, inside concentration is high. Therefore, water enters into the resin, and this will become grape. This becomes grape. So all this process is due to osmosis, right? So the movement of solvent particles from low concentration to high concentration. మనం ఎప్పుడైనా హై టు లో అంటాం. పర్ఫ్యూమ్ ఎట్లా డిఫ్యూజ్ అవుద్దామో, పర్ఫ్యూమ్ డిఫ్యూజెస్ ఫ్రమ్ హై కాన్సన్ట్రేషన్ టు low concentration, right? Anything moves in this way, like only in osmosis. So this happens low concentration to high concentration, or high water potential to low water potential. The water is going to move. This is what you call it as osmosis. Okay. So here, so we have to call 2 more words here. We have seen what is isotonic, and we will see what is isotonic. Tarvata we have got hypotonic solution. hypotonic solution, and this is called hypertonic solution. So the difference between these two is, in hypertonic solution, what osmosis takes place? Exoosmosis takes place. In hypotonic solution, right? So what osmosis takes place? Endoosmosis takes place. Hypertonic, hypotonic solutions. Rendu ardhamainandi? Do you understand the difference between these two? Hypertonic, hypotonic, and we have got isotonic. Isotonic is very simple. Iso means same. If the pressure, osmotic pressure is same, you call them as isotonic solutions. And hypotonic, hypertonic solutions are different solutions. Right? So I'll tell one more real example here. If you shift a fish from sea into fresh water, if you shift a fish into fresh water, what will happen? Or if you shift a fish from fresh water to saline water, that is marine water, sea water. Cheppandamma emavuddi? Do they survive sea water? Do they survive if I do this one? If a fish is migrated from sea water into fresh water, or a fish from fresh water into sea water, are they going to live like that? Are they going to die? చెప్పండి అమ్మా, ఆలోచించండి. Let us say in a pond, if one fish is living in a pond, अगर एक फिश यहाँ जी रहे, तो आपको ये सोचना है इसका वाटर का पाई एंड फिश का पाई दोनों सेम होना है. देन ओनली फिश कैन सर्वाइव. Fish can survive. So a fish always would like to swim or live in a water or in a solution where the osmotic pressure of both are equal. If these are unequal, what will happen? Either water enters into the fish by endoosmosis, or water may go out by exoosmosis. So these type of things will happen here, right? Osmosis, hypertonic and osmosis process. Okay. So we'll go to our NCRT and we'll check what is given here. Right? Examples are given here. This is osmosis process. And we have to talk about reverse osmosis. Cheppandamma, reverse osmosis. The osmosis process is reversed when applied force is applied opposite to the flow of solvent. Right? So this is the method by which we generally purify salt water or the sea water by reverse osmosis. And we have in all our homes, we have RO plants, the water purifier, which contains, we know the word RO. RO means reverse osmosis. It is nothing but reverse osmosis. So just we have to do it. So here is the experiment here. You have got the salt water here and you have got the fresh water here. So what should be done here? The salt water and fresh water are separated by semi-permeable membrane. And here you have salt water which is connected to a small piston here. So what shall we do here? We apply some pressure over this piston, right? So if we apply the same pressure equal to osmotic pressure, the osmosis process continues. If we don't apply osmosis, fresh water tries to flow into the salt water. This is the regular process. But what we do now here, we apply high pressure. Then what will happen? The salt particles, the solvent particles are forcibly transferred through the semi-permeable membrane by means of external force. So reverse osmosis process. Osmosis is a natural process. Osmosis is a natural process, whereas reverse osmosis is a non-spontaneous process. Osmosis process generally happens in the universe, right? So our blood, our formation of urine, and many biological reactions take place in and out of a cell due to this osmosis process only. But that's a spontaneous process. But if you would like to reverse the process of osmosis, we call it as reverse osmosis, where we apply the pressure. Now the solvent particles are forcibly transferred back into the fresh water, so you will get the fresh water from this. Generally, so this type of fresh water is sea water. Generally sea water is converted. Sea water is very salty hota hai, highly concentrated hota hai, so that is converted into fresh water by majority of the boat sailors. You know the boat sailors, they travel on sea for years or months, like 6 months. They start from America and they reach India by 3 months. So during those 3 months of time, so they need water, but they can't carry the water with them with the boat. Why? Because water is very heavy, they can't do it. So that's why they will fix a reverse osmosis equipment in their boat, and that will take the sea water and convert it into fresh water, and they can use it for what? They can use it for domestic purposes. This is what you call it as reverse osmosis, right? So reverse osmosis won't take place all by itself. It needs an energy. External energy is required for it, right? So यहाँ दिया हुआ देखो, the direction of osmosis can be reversed if a pressure of larger than the osmotic pressure is applied to a solution. That is, now pure solvent flows out of the solution through the semi-permeable membrane. This phenomena is called reverse osmosis and is of great practical utility. The reverse osmosis is used in desalination of seawater. Desalination, removing a salt from the seawater, is the desalination process. A schematic setup process shown here. When pressure is more than osmotic pressure is applied, the pure water is squeezed out of the seawater through the membrane. So a variety of polymer membranes are available for this purpose, right? So the pressure required for the reverse osmosis is quite high. A workable porous membrane is film of cellulose acetate placed over suitable support. Cellulose acetate is a semi-permeable to water. Cellulose acetate, here is the substance given. Cellulose acetate is a semi-permeable membrane for water, but impermeable for impurities like ions present in the seawater. So these days, many countries use desalination plants to meet their potable water requirements. So desalination is a very common process in island nations. In our region, in Telangana region, we don't have access to sea. That's why we don't know this process at all. But this process is very common if you are sharing your border with the sea. So sea water can be converted into pure water by using this technique. Okay. Yeah, next we'll move to Yeah, we'll conclude it. Before we conclude, abnormal, we have got this colligative properties. So all colligative properties we just summarize, then we'll go to another topic, that is, so we have seen relative lowering vapor pressure. So formula చెప్పండి, P naught minus PS by P naught equal to x2 అంతేనా, x2 which is equal to W2 by M2 into M1 by W1. So this is the RLVP. Second one is depression, elevation in boiling point. Elevation in boiling point. So in elevation in boiling point, what is the formula? Delta TB. Delta TB equals to KB into W2 by M2 into 1000 by W1. So this is the formula we used for elevation in boiling point. The next one, third one is depression in freezing point. Depression in freezing point. So where, what do we use here? Delta TF equals to KF times W2 by M2 into 1000 by W1. Right, this is depression in freezing point. And the last but not the least one, the fourth one is osmotic pressure. Yeah, osmotic pressure. So which we denote it like, so the pi equal to CRT, or molar mass formula రాయాలంటే molarity formula రాద్దాం. W2 by M2 into RT into 1000 by V in ml. So these three terms are molarity terms. So these are the colligative properties what we have used. ఇక్కడ చూడండి ఒక చిన్న డిఫరెన్స్ ఉంది. The purpose of all colligative properties is to find the M2 only. All of it has a property to find the M2 only. सबका molar mass find करने के लिए तो we use this, right? So but in first case, for RLVP we use mole fraction. For second two cases we use molality. For third case we use molarity. Why is it so? You can't use molarity here because elevation in boiling point is observed by heating a solution. If you heat the solution, molarity changes with the temperature. Molarity is the temperature dependent. So molarity changes, that's why we are using molality in elevation as well as in depression. In osmotic pressure, we have to use the concentration because you have to, the osmotic pressure changes according to the temperature. Temperature change हो गए तो osmotic pressure also changes, right? So that's why temperature को भी include करना है आपको, इसलिए we use molarity here. तो इसके लिए mole fraction use करना है. Molality भी use कर सकते, but mole fraction is bit easier way to use it. That's why these are the four colligative properties you should able to do it. Okay, so then ఒకసారి you have to list out all we have discussed about these four colligative properties only, right? So దీనికి గ్రాఫ్ లేదు, దీనికి గ్రాఫ్ ఉంది, దీనికి గ్రాఫ్ ఉంది, దీనికి కూడా గ్రాఫ్ ఉంది. దీని గ్రాఫ్ ఎట్లుందో ఒకసారి చెప్పండి. సో ఎలివేషన్కు గ్రాఫ్ ఈజ్ లైక్, సో వి గో లైక్ దిస్, రైట్? సో ఇక్కడ వై యాక్సిస్ ఉంటుంది, వై యాక్సిస్ పైన ఇది 1 atm ప్రెషర్ ఉంటుంది, రైట్? సో ఏ వాళ్ళ ఇక్కడ టెంపరేచర్, దిస్ కరెస్పాండ్స్ టు హయ్యర్ టెంపరేచర్ కాబట్టి, సో దిస్ ఈజ్ సాల్వెంట్ and this is what? Solute. This is solute. డిప్రెషన్కి వచ్చినటువంటి గ్రాఫ్ ఎలా ఉంటుంది చెప్పండి, ఇది కింది వైపు వస్తుంది. సో యూ కనెక్ట్ ఇన్ దిస్ వే, రైట్. సో పైన ఎక్కడో ఉంటుంది. సో దిస్ లో టెంపరేచర్, దిస్ ఈజ్ హై టెంపరేచర్. హై టెంపరేచర్ ఈజ్ T0, so this is T1, right. Depression in freezing point. So this difference is gives you delta TF. The difference between these two lines gives you delta TB. So this is what the conclusion of the colligative properties. Yeah, we'll conclude the topic today. So by seeing abnormal molar masses. Abnormal मोलार मास, ये क्या होता है देखेंगे एक बार. So these colligative properties what we have used, these are useful for ideal solutions. If your solution is ideal, you can use these things. If your solution is non-ideal, so what is the meaning here? The colligative properties which depend upon count of particles only, number of particles, count of particles only, not the nature of the particles. If your count increases, your colligative property increases. If your count decreases, the colligative property decreases, right. So that's why you say it as the particles which depend upon only the number or count of particles is the colligative property. This is very true in case of ideal. If a solution is ideal, it is very true. But in case of non-ideal solution, for example, मैंने NaCl लिया एक, this is 1 NaCl. How many moles of are there here? 1 mole of NaCl is present. But if I dissolve this in water, what will happen? If I dissolve this in water, if I put some water in it, so NaCl will be dissociated to give Na plus and Cl minus ions, right. So here the count is 1, but here the count is 2. Here the count is 2. So if a molecule, one molecule dissociates into small tiny particles of 2, then the molar mass calculated by using a colligative property gives you an error. So that is not going to be correct, isn't it? For example, NaCl nu vesi, if you have depression, if you calculated the depression or elevation in boiling point, so that will add, that is not going to be the right one. Why? Because you are thinking about one atom, but you have got 2 when they are put in the water. So the count has been doubled, right? The count has been doubled. The count has been doubled, therefore the count doubles, definitely molar mass calculated by the colligative properties is going to have the error, right. So this is applicable for non-ideal solutions. So for all non-ideal solutions, so we have to correct these solutions, right. So for calculating abnormal molar mass, what we use, the most important, we use Van 't Hoff factor. So what is Van 't Hoff factor? Just we'll see it, then we'll go into this Van 't Hoff factor. So this is Van 't Hoff factor. So what is the meaning of the Van 't Hoff? Van 't Hoff is the name of the scientist who has given correction occurred in this cone, right? So Van 't Hoff in a spelling kuda variety undadu chudandi, Van 't Hoff factor, రైట్. సో వంట ఫ్యాక్టర్లో సింపుల్ అండ్ ఏం లేదు. హీ హ్యాస్ గాట్ వంట ఫ్యాక్టర్ వి డినోటెడ్ బై స్మాల్ ఐ. స్మాల్ ఐ తోటి డిఫైన్ చేస్తాం అంతే, రైట్. సో అకార్డింగ్ టు ద వంట ఫ్యాక్టర్, the colligative property calculated should be corrected by want of factor. What is the meaning of it here? So we have RLVP, that is P naught minus PS by P naught equals to x2 కదా. x2ను ఏం చేయమంటాడంటే దీన్ని you have to multiply it by want of factor I. యూ హ్యావ్ టు మల్టిప్లై ఇట్ బై ఐ ఫ్యాక్టర్ తోటి దీన్ని మల్టిప్లై చేయాలంతే. ఐ వాల్యూ ఏంటిది అనేది తర్వాత చూద్దాం. సో వీ హ్యావ్ గాట్ డెల్టా టీబీ విచ్ ఈజ్ ఈక్వల్స్ టు ఏంటమ్మో ఫార్ములా ఏంటి? డెల్టా టీబీ ఈక్వల్స్ టు కేబీ ఇంటూ మొలాలిటీ, బట్ అకార్డింగ్ టు వంట ఫ్యాక్టర్ you correct it by I. Delta TF అంటే చెప్పండి. డెల్టా TF ఈక్వల్స్ టు KF into molality, but if you have association dissociation you correct it by I. What is the osmotic pressure? So pi equal to CRT. This is the osmotic pressure, so it has to be corrected by I. So these are the colligative properties corrected by want of factor. Want of factor తోటి కరెక్ట్ చేసిన తర్వాత ఇలా వస్తుంది. All you need to do is, if want of factor is 1, then there is no problem, isn't it? So it will be, if I is not equal to 1, then only you have to use it, otherwise you don't have to use it. Right. So in a molecule, if association takes place or if dissociation takes place, we have to use this want of factor and correct it by this. So how exactly we do it? We also see that, right? Exactly how we do it. Want of factor calculate करने के लिए we have formulas to calculate. Right. So by using I factor can be calculated by 3 methods. Right. ఇక్కడ ఉన్నాయి చూడండి, ఇక్కడ ఉన్నాయి. So want of factor can be calculated by using this formula. So I can be calculated by using these 3 formulae. చూడండి ఒకసారి ఫార్ములాలు చూడండి జాగ్రత్తగా. సో I equal to normal molar mass by abnormal molar mass. సో ఇక్కడ normal molar mass by abnormal molar mass, this is the one formula, which is equals to observed colligative property by calculated colligative property, and number of moles of particles after dissociation divided by number of moles or particles before dissociation. So these are the 3 formulae to calculate the I factor. So ఇవి ఒకసారి రాసేసుకోండి. నార్మల్ మోలార్ మాస్ బై అబ్నార్మల్ మోలార్ మాస్, observed colligative property by calculated colligative property, right? So before after, so I number of moles after by before. Calculated is before, so abnormal is before, so మీద normal things undali. So these 3 formula you should remember. I value can be calculated, రైట్. ఒకసారి రాసుకున్నామా ఇది ఐ వాల్యూ ఎట్లా క్యాలిక్యులేట్ చేస్తాడు. ఎట్లా చేస్తాను చెప్పండి. ఇప్పుడు మనకు ఒక నార్మల్ మోలార్ మాస్ ఇస్తాడు కదండి. ఫర్ ఎగ్జాంపుల్ NaOH తీసుకుందాం 40. అబ్నార్మల్ మోలార్ మాస్ ఆఫ్ NaOH ఈజ్ 20 అనుకో. సో ఐ ఫ్యాక్టర్ ఎంత వస్తుందమ్మా? 2 వస్తుంది. అబ్జర్వ్డ్ కాలిగేటివ్ ప్రాపర్టీ 100 ఉంది అండ్ క్యాల్కులేటెడ్ కాలిగేటివ్ ప్రాపర్టీ 25 ఉంది. సో ఇఫ్ యూ कैंसल दिस हाउ मच यू गेट 4. जस्ट यू हैव टू डू डिवाइड करने से आपको आई फैक्टर मिल जाएगा. एंड abnormal molar mass is given, normal molar mass we know it, observed colligative property is given and calculated colligative property you have to calculate it. Total number of particles after dissociation is given, before dissociation is equal to its concentration. చూడండి ఇక్కడ పైన ఉన్నవన్నీ న్యూమరేటర్ వాల్యూస్ ఆర్ గివెన్ and denominator values are constants every time they are constant. Okay, right, so here comes so one more point we should remember. I calculate करने के लिए we have one more formula by which you can calculate the I value of any substance given to you. So that is ఇది అందరు రాసి పెట్టుకోవాలండి. I equal to 1 plus n minus 1 alpha. So this is the formula to calculate the I. So what are the terms? We just note it down. Right, what is alpha andi? Alpha is degree of dissociation. What is n? N is for, let us say for NaCl, n is how much? 2. For Na2CO3, Na is 3. Yes. For MgCl2, what is n? 3. Number of ions produced on ionization by an ionic compound is n. So how much is it for glucose? C6 H12 O6. So దీనికి ఎన్ని వస్తాయి? 1 వస్తాయి. Degree of dissociation will be given in the question, otherwise it will be given. So when it will be given, आपको परसेंटेज दिया जाएगा, इसको 100 से डिवाइड करने से आपको अल्फा मिल जाता है. And I is generally want-Hoff factor. This is what? Want-Hoff factor. Want-Hoff factor is the I. So this is how you have to use this formula. इसको थोड़ा मॉडिफाई करेंगे. So formula is I equal to 1 plus n minus 1 alpha. దీని నుంచి ఆల్ఫా తీసుకురావాలమ్మా. ఆల్ఫా ఈక్వల్ టు ఏమొస్తుంది చెప్పండి? n minus 1 alpha equal to I minus 1, అంతేనా? ఆల్ఫా ఈక్వల్ టు I minus 1 by n minus 1. సో ఇట్లా కూడా I ఇస్తే ఆల్ఫా క్యాల్కులేట్ చేయవచ్చు. If I is given, n you know, using this formula you can calculate this one. This formula isn't there in NCERT, so you need to take a note of it. Colligative property, Want-Hoff factor you should remember. Right? ఇక్కడ కూడా 2 కేసులు ఉన్నాయమ్మా. ఇంకొక కేసు ఏంటంటే జనరల్లీ NaCl gives you Na plus Cl minus. This is dissociation. Right? But when you take CH3COOH, 2 moles of it, CH3COOH, so it will be dimerized. CH3COOH taken twice. In this case, dimerization is taking place. This is what you call it as dimerization or association. So for dissociation you have to use this formula. For association, n should be written 1 by n. 1 by n. I'll write both the formula here. Both formula I will write here. So I equal to 1 plus n minus 1 alpha. This is for dissociation. Dissociation. Right? So when we write I equal to 1 plus, it is 1 by n minus 1 alpha. This is for association. Association and dissociation. So దీని నుంచి ఫస్ట్ దానికి ఆల్ఫా రాస్తే ఏమొస్తుంది? I minus 1 n minus 1 వస్తుంది. సెకండ్ దానికి ఆల్ఫా ఈక్వల్ టు I minus 1 by 1 by n minus 1 వస్తుంది. సో ఈ రెండు ఫార్ములాలతోటి ఆల్ఫాను మనం క్యాలిక్యులేట్ చేయవచ్చు. Percentage of dissociation can also be calculated using these two formula. ఈ ఫార్ములాలు 4 ఫార్ములాలు ఉన్నాయమ్మా, వీటిని రాసుకోండి, ఎన్సీఆర్టీలో కూడా రాసేసుకోండి. వై? బికాస్ దిస్ ఈజ్ వెరీ వెరీ ఇంపార్టెంట్. Okay, so we'll conclude here. Thank you.